and I will, dear colleagues, we will continue the chain of our scientific seminars named of intellectual theater. And today again with us, the eminent philosopher and mathematicians from India, Dr. Praveen Agarwal, who will make report today on some mathematician issues. Please, dear Dr. Praveen.
Yeah, thank you very much, Professor Rojana. And I request to the Lilia, please give me a permission to share my slides. Yeah. So I hope my slides are visible. Please confirm, anyone.
Yes, it's visible.
Yeah, so thank you very much once again, all the participants on this online conference, and it's a really thankful to you, Professor Rojana, to give me a opportunity to share my research via this platform. So today I am going to giving the some of the information regarding the Elzaki transform of pathway fractional integral involving the extended hypergeometric function in the kernel. So friends, I belong to the Department of Mathematics, Anand International College of Engineering, Jaipur, and I also associated with the People's Federation University of Russia, RUDN University, under the one of the project, bilateral project, under the supervision of Professor Ruzana. So the outline of my talk is the abstract keywords, introduction, main result, conclusion, acknowledgement, and references. Here, major goal is to present Elzaki transform of pathway fractional integrals involving extended hypergeometric function in the kernel of different parameters. Some particular cases are also discussed by putting specific values to the parameters. These are the keywords, and in the recent times, several generalization of classical functions witness a remarkable change. This evaluation in the area of classical functions offers as an analytical foundation base for the several problems in physics and engineering, mathematics, which have been resolved entirely and which have many practical uses. The complete concept of classical functions depend on some main basic spatial functions, that is beta function, gamma, and hypergeometry functions, because most of the spatial functions are expressed in terms of the gamma functions. In the last few years, the area of classical functions, mainly generalization of classical functions, have been one of the fastest growing topic in mathematical theory, because scientists observe that it is necessary to analyze the properties of these functions with their changes domain, due to which many researchers and scientists are constantly working in this field. During this work, real part of Z denoted the real part of Z, C set of complex number, LAB the space of Lebesgue integrable function on AB. Here we mention some non-spatial functions and formal important research. So I can show you the beta function and gamma function are defined by the one of the definition you can see in the equation number 1, which is defined by the beta function. And this is the classical definition of gamma function, which is given by the equation number 2. And the generalized beta function is defined by the equation number 3, which is given by in terms of the Wieman's function, and E of A1, A2, Z is called the Wieman's functions. Further, several uses of hypergeometry functions found in many fields of mathematics, physics, engineering, and sciences. For example, 2F1. The 2F1 is a solution of homogeneous second-order differential equation, which is called the hypergeometric differential equations, given by the equation number 4. 2F1 is given as in a summation formula by the given number equation number 5. Here, W of L is presented the Poggenper symbol given by the W of L gamma WL plus upon gamma of W, and it is value is 1 when L equal to 0, and the value is L belongs to the N, then W plus 1 up to the W plus L minus 1. Then power series representation of 2F1, which is given by the equation number 6. The Kumar replacing the values z by z upon b1 and taking limit b1 tends to infinity in the equation number 4, then hypergeometric differential equation becomes confluent hypergeometric differential equation or Kumar's equation, which is given by the equation number 7. The 1F1 is the solution of the above differential equation 7 is defined by the in summation form by the equation number 8, and we call it as a confluent hypergeometry function. Then power series representation of 1F1 is given by the equation number 9 in the term of the two beta functions. Both are the classical beta functions. Recently, a number of researchers have considered many results of various hypergeometric operators of fractional integration. In 1903, the Mittag-Leffler function developed and various composition formula and extension including important application had been performed and studied. The Mittag-Leffler function E-A1Z and E-A1A2Z had been composed in various results which may apply in many areas of research. Here I mentioned that the Mittag-Leffler function is a very, very powerful function to deal with the engineering problems as well as space problems. So, and as well as recently we use these Mittag-Leffler function to deal with some mathematical models related with the solar energy, related with the pandemic models. So they are very, very powerful functions. Further, some uses of these functions are found in solving the problem of earth science. As I mentioned that it's earth science, and the engineering machine learning functions are the generalization of an exponential function. Mittag-Leffler function is given by one variable is given by the equation number 10. You can see at that, then it is a convergent when real part of A1 is greater than equal to 0 and Z belongs to the C. Then Women's function is defined by the equation number 11, and it is convergent when real part of A1 is greater than equal to 0 and A2 greater than equal to 0. Very recently, inspired by the above all mentioned work done by the many researchers, me and one of my collaborator, Professor Jain, have introduced new extension of the 2F1 and 1F1 function using the extended beta function and discuss various results of these extended functions. The extended 1F1 is defined as follows. You can see in the equation number 12. So it is defined by the following definition involving the classical beta functions and generalized beta function, and the extended 2F1 function, which is defined by in terms of the generalized beta function and the classical beta function, which is given by the equation number 13. The convergence conditions is already given at here, and B of A1, A2 is the extended beta function defined in 10. In mathematics, convolution is a mathematical method on two functions F1, F2 that includes a third function F1 star F2 that indicate how the shape of one is changed by the other. The theory of fundamental product of a function F1, F2 is circular to prove our work. Handmade product F1, F2 given by the equation number 14. You can see that at here, it is given by the equation number 14. So here F1, F2 be to 2 power series defined as F1 equal to summation n equal to 0 to infinity Ck z of k, and F2 is defined by the n equal to 0 to infinity dk z of k, whose radii of convergence are denoted by R of F1 and R of F2 respectively. The fractional calculus is an extremely developed area of mathematics that has extensive consequences on daily life. and life subject, fractional calculus deal with derivatives and integrals of fractional order, which involve complex number as well. A short time ago, this area attracted many researchers and scientists due to its many properties and numerous applications in almost every field of engineering mathematics. The fractional integral operators, which includes some well-known classical function in it, has significant value, and its application are used in many a sub area of applicable mathematical sciences and many areas such as control, thermonuclear, stochastic dynamical system, turbulence, fluid dynamics, and fusion and image processing. In 2009, Nair has established a pathway fractional integral operator by using the pathway idea of Mathai, and Hubbard. Consider HW belongs to the LCD, mu belongs to C, such that real part of mu is greater than 0, and C is greater than 0, and consider pathway parameter beta is less than 1. Then pathway fractional integral operator is given by the equation number 15, and the symbolical notation is represented by the P. It is a representation of the pathway operator. The probability density function of pathway model for scalar random variable is defined by the equation number 16. Then, given that the condition beta belongs to the R and W is greater than minus infinity, less than infinity, gamma is greater than 0, alpha is greater than 0, and with the condition of these, the beta is called the pathway parameter and K is the normalized constant. In recent time, me and one of the research scholar have studied the pathway fractional integral formulae involving extended hypergeometric function as follows. So here it is represent the pathway fractional operator, and this is the generalized Gauss hypergeometric function. We involve it and we got the result in terms of the classical beta function and generalized 2f1 Gauss hypergeometry function, and in terms of the phi, and the convergence of the result 17 is given by the following conditions. So on the same way, when we got the another result, which is given by this is the pathway operator, and this is the confluent hypergeometry function, and the result is becomes in terms of the classical beta function and the invert product with the two phi functions, which is given by the equation number 18. So both differentiation and integration transform change a function into another function, whereas Elzaki is also an integral transform with the interval of integration is unbounded interval 0 to infinity, and e raised to power minus xyv as a kernel provide a particular type of transform called Elzaki transform. In general, Elzaki transform changes the functions of z variable into the another variable of v variable. It is obtained from the Fourier integral, depends on the mathematical simplicity of the Elzaki transform and its main result. Elzaki transform was investigated by the Elzaki to facilitate the process of solving ordinary and partial differential equation and their time domain. The Elzaki transform for the functions of exponential order by the Elzaki as considered the function in the Z, and it is defined by the Z is represented by the following representation. Consider a function which is in the set Z, the constant W must be the finite number. So many n1, n2 may be the finite or infinite. The Elzaki transform represented by the operator E of dot. The E of dot is defined by the equation number 19, and it is a very, very important transform formula. Here, the convergence is given by the V is greater than equal to N1 and less than equal to N2, and variable W in this transform is used to factor the variable X in the argument of the function H. E of Hx is defined by the equation number 20. The Elzaki transform of the function f of x equal to x raised to power n is given by the equation number 21. We recall the Laplace transform is defined by the equation number 22. So the Elzaki transform certainly deals all problems that are usually deals with the Laplace transform. Elzaki transform has deeper connection with the Laplace transform because after some suitable substitutions, Elzaki transform becomes Laplace transform Fs, then Elzaki transform Ft is given by the following representation. Here, this remark is showcase some important relationship between the Elzaki transform and the Laplace transform. You can see that by the equation number 23 and 24. It shows that if we took the t equal 1 equal to f of 1, then Elzaki and Laplace transform must coincide at w equal to s equal to 1. So the equation 23 and 24 from the duality relation governing these two transforms may serve as a mean to get one from the other when needed. Then we studied Elzaki integral transform term T of pathway fractional integral involving extended hypergeometric function in the kernel given in 17 and 18 is showcased by this theorem. You can see that this is a Elzaki transform which is shown by there, and it is a pathway operator and it is a generalized hypergeometric function. When we operate this Elzaki transform at here, and we got the result in terms of the equation number 25. Due to the time limit, I am not giving the proof of this result at here, so I am skipping the proof. Yeah. Then this is another theorem. Here E is the Elzaki transform, and this is the pathway fractional integral operator, and this is the generalized confluent hypergeometric function. Then the result becomes in terms of the equation number 31. Okay. Now we go to the another part. And you can see that what happened. Okay, and then it becomes the proof we are not showing it here due to the time limit. Yeah, the special cases. Here we discuss some special cases by substituting particular values to the parameters. So you can see that in this equation theorem 1, we put the some specific value, then we got the classical Gauss hypergeometry function. In the similar way, if we put the specific value in the generalized confluent hypergeometry function, we got in theorem 2, we got the classical confluent hypergeometry function. And corollaries, if we put the some specific values in theorem 1, then we got the result is given by the equation number 39. And similarly, we got the relation number is 40. So we complied our current research by remarking further that the result acquired here by the Elzaki transform with pathway fractional integrals involving extended hypergeometric function in the kernel are properly important. Firstly, we have studied the Elzaki transform of pathway fractional integrals involving extended hypergeometric functions. Then we have also discussed some particular cases of the main results. The results existing in our study are relied upon to lead to some potential application in many areas like physics, engineering, earth science. Further, we can also use our main results for the further investigations of the following result given in the papers published in last year. So I am also thankful to this work was prepared within the framework of the agreement between the Ministry of Science and Higher Education of the Russia number 0751520211603, developed of the new methodology and intellectual base for the new generation research of Indian philosophy in correlation of the main world philosophy tradition. This work has been supported also by the RUDN University Strategic Academic Leadership Program. And these are my references which I have used to find out these results. You can see that the most of the work is related with the generalization of the spatial functions and the fractional calculus. Yeah, these are the references. Yeah, thank you. Thank you very much. And if any question, then most welcome.
Thank you very much. Okay, thank you very much, dear Praveen. We will post this recording video again on our YouTube channel of our center. So we will meet again in several days. Yes?
Yeah, thank you very much, Professor Rujana, and all the colleagues.
Thank you, Dr. Praveen. See you later. Bye.
Bye bye. Bye bye.